Okay, so since it gives us f of negative 2 equals 7, we can use the fundamental theorem of calculus to solve for these two values. And we have that the integral from negative 2 to x of f prime of x dx equals f of x minus f of negative 2, which is just 7. So to find f of negative 6, so this is negative 4, and then we add 7 to both sides, and we get that 3 equals f of negative 6. And then we move on to finding f of 5, and we get that the integral from negative 2 to 5 of f prime of x dx equals f of 5 minus f of negative 2. Now the integral from negative 2 to 5, we know that the area of this triangle is 3 since it has a base of 3 and a height of 2. And this is half of a circle with a radius of 2, so its area will be negative 2 pi, and it's negative because it's under the x-axis. So we get that the total area from negative 2 to 5 will be this plus this, so 3 minus 2 pi, which equals f of 5 minus f of negative 2, which is 7. So we add 7 to this and get 10 minus 2 pi equals f of 5.
We're supposed to find on what intervals is f increasing, and f will be increasing when f prime, the slope of f, is positive. Since it gives us the graph of f, we just have to determine where this is positive. And this is positive from here to here, and from here to here. So on what intervals is f increasing? It will be increasing from negative 6 to negative 2, and 2 to 5. And for the justification, we put because f prime is greater than 0 on these intervals.
C, we have to find the absolute minimum value on the closed interval. And since it's the absolute minimum, we have to find we use the extreme value theorem. So since we're using the extreme value theorem, we have to find all the critical points, and the critical points are where f prime equals 0, and according to this graph, that happens at x equals negative 2 and 2. So we have to test f of x at both endpoints and all the critical points to find the absolute minimum. So we have x and f of x of negative 6, negative 2, 2, and 5. Now we know that f of negative 6 equals 3 from the previous part of the question. We know that f of negative 2 equals 7. And we know that f of 5 equals 10 minus 2 pi from part A. To find f of 2, we can use the integral from negative 2 to 2 of f prime dx, which equals f of 2 minus f of negative 2. And the integral from negative 2 to 2 is negative 2 pi, which equals f of 2 minus 7. Add 7 to both sides, and we get 7 minus 2 pi equals f of 2. Now, of these four values, 7 minus 2 pi is the lowest one, so that means this will be our absolute minimum. And the justification is the table and saying that we use the extreme value theorem.
Part D, find f double prime of negative 5 and f double prime of 3. So f double prime will be the slope of this graph, f of prime, f prime. So to find f double prime of negative 5, we can just find the slope from the basic slope formula. We can use the points negative 4 and negative 6. So f of negative 4 minus f of negative 6 over negative 4 minus negative 6. And that will give us 1 minus 2 over 2, which equals negative 1/2. So that is f double prime of negative 5. Then f double prime of 3, let's go up here, does not exist. And it's asking us for a justification. Explain why it does not exist. It does not exist because there's a cusp at x equals 3 on the graph of f prime. So f prime is not differentiable at x equals 3.